All right, now in this case, we'll be treating laws of indices. Indices has to do with powers. Another word for indices is exponent. Indices is the plural of the word index. Okay, so we have multiplication law, we have division law, we have zero index law, we have power law, then we have negative index law as well as fractional index law. Okay, now when you talk about index, it means power of a base value. Okay, now considering this multiplication law, it says that if the bases are the same, take one of the bases and add up the powers. Now look at this, the first example, AA, the bases are the same. So we take one of the bases and add up the powers. Because of multiplication, we add up powers. Now look at this with a power of numbers. I have 2 raised to the power 3 times 2 raised to the power 2 equals to 2 raised to the power 3. Because of times, we now say plus. We add up this other one, taking one of the bases, okay? And then we have 2 raised to the power 2 plus 3 plus 2 is equals to 5, which is equals to 32. Of course, this 32 is gotten from, let's say 2 times 2 times 2 times 2 times 2. That's 2 raised to the power 5. 1, 2, 3, 4, 5. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. All right. Now look at this other problem. We have 4 raised to the power s times 8, which is equals to 2 raised to the power. Now we have to, this one, the bases are not the same. So we ought to find a way to make them the same. Of course, the common base for this is 2. We cannot use 4 because 4 raised to the power 2 will give us 16, which is more than this 8. So the common base should be 2. And then we have 2 raised to the power 2 only gave us 4. And then the already existing power will enter inside the bracket to multiply the new one. Now times 2 raised to the power 3 is equals to 8. That's 2 times 2, 4. 4 times 2, 8. Okay? All right. So now that the bases are the same, we take one of the bases and add the power, which is 2 times s is 2s. And then because of times, we now say plus 3. Okay? You can replay the video. If you didn't understand very well, you'll understand it in subsequent teachings. All right, we have 4. This is 5 times 125 equals to 5 raised to the power 1 times 5 raised to the power 3. Of course, any 3 raised to the power 1 is itself. Okay, this is having invisible 1 here. Now we have 125. That's 5 raised to the power 3. 5 raised to the power 3 implies, let's say 5 times 5 times 5. Okay, which is 5 times 5 is 25. 25 times 5 is 125. Okay, so we now have to take one of the bases. The bases are not the same. They are now the same. We say we now add up the powers. That is the first one, because of times we say plus 3 equals to 1 plus 3 is equals to 4. Okay, with the same base. Now 5 raised to the power 4 is equals to 625. That's 5 times 5, 25. 25 times 5 is 125. 125 times another 5 will give us 625. All right. Now the next law is division law. The only difference between this division law and multiplication law is that instead of adding up powers, we'll be subtracting the powers. Okay, that's just simple. Now we now have I as the first example under division law. We have a raised to the power 3 divided by a raised to the power 2 equals to a raised to the power 3 minus 2, which is equal to a raised to the power 1 equals to a. Okay, all right. So how do we do that? This minus here is for this division. We subtract power. 3 minus 2 is equals to 1. 3 raised to the power 1 is equals to itself. Now we have 2 raised to the power minus 1 divided by 2 raised to the power minus 4. Okay, this is another question. And this implies we take one of the bases. Since the bases are the same, take one of the bases and then subtract power, which is minus 1 is here. Because of division, we put minus. Now this one is already having minus, so we put it in bracket. Sorry, to not conflict with this one. And since it's in bracket, to multiply this one out. We now say equals to 2 raised to the power minus 1. This minus 1. Minus minus is equals to plus. That's minus times minus equals to 4. Equals to plus. Then we have 4 here. All right. So we have equals to 2 raised to the power minus 1 plus 4. Let's say you are owing 1 when you got 4 and you pay the 1, you'll be having 3. That's positive 3. That's 2 raised to the power 3 minus 1 plus 4 is equal to 3. Now, 2 raised to the power 3 is equal to 8. 2 times 2, 4, 4 times 2, 8. All right. Now, the third question there is 16 raised to the power 2x divided by 4 raised to the power 3x. Okay, 3x. We have equal to. Now, the bases here are not the same. We are meant to make it the same. Now, of course, this is 4. If you raise 4 to the power of 2 to give us 16, because 4 times 4 is 16. So instead of 16, now we now use 4 raised to the power 2. And then the new existing power will multiply this new one. We'll put it in brackets. Now divided by the same value we have here. Okay, all right. Now, which is equals to since the bases are not the same, we take one of the bases and subtract power because of division. We now say 2 times 2s equals to 4s. Because of division, we say minus and then 3x equals to 4 raised to the power x. Okay, now we have 4. The first question here is 625y divided by 5 raised to the power 2y, which is equals to 5 raised to the power 4 brackets y. That's 5 raised to the power 4 is giving us 625. Then the already y will enter bracket and multiply out. Divided by, this is still what it is. Now the bases are the same. Okay, now take one of the bases. 4 times y is equals to 4y. Because of division, we say minus, then 2y equals to 4y minus 2y is equals to 2y. So we have 5 raised to the power 2y. Now under zero index law, we say any value raised to the power of 0 is equals to 1. Okay, now we have a raised to the power 0 is equals to 1. When we have a question like 2 raised to the power 3 divided by 2 raised to the power 3 is equal to 2 raised to the power 3 minus 3. Okay, because of division we say minus. Okay, now 3 minus 3 is equal to 0 and we say it's equal to 1. This is a proof with another method. Now we have 2 raised to the power 3 divided by 2 raised to the power 3, same thing with this. Okay? Now 2 raised to the power 3 can be dissociated like this. And then we now have 2 times 2 times 2. 2 times 2 times 2, that's 2 raised to the power 3. Now 2 into itself 1, 2 here, 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 1. And then 1, 2, 3, 1 times 1 times 1 is equals to 1. Okay, and then 1 times 1 times 1 is equals to 1, which is equals to 1. Okay, because 1 over 1 is equals to 1. So that's how we prove it. Now power law, new powers multiplies old power, just like we've been doing here. We have 2 raised to the power x times 8 raised to the power 2x, making the base the same. We have 2 raised to the power s times 8 here is equal to 2 raised to the power 3. Now what's the main power law there is this power, as in the already existing power multiply the new power. Okay, which is 3 times 2s equals to 6s. We take one of the bases and then we work it out, just like we did in the multiplication law. All right. The next one there is negative index law. Under negative index law, we say negative signs in power values are treated as reciprocals or causes inverse of the base values. Now, look at the question. The one question we can use to justify this. We have 4 raised to the power minus 2 equals to this negative sign here, that's negative index, is treated as reciprocal. Okay, that's 1 over or inverse. All right, that's inverse of 4 is equals to 4 is something like 4 over 1. So when you inverse it to become 1 over 4. Now the 2 here will still maintain as a power, which is equals to 1 over 2. 4 raised to the power 2 is equals to 16. Okay, now at this point we have fractional index law. All right, now under this law we have the numerator of the power is treated as root value, while the denominator is treated as power of the value inside the root sign. Now let's just find with example. Say it's 125 raised to the power 3 over 2. This is a fractional index, it's a fraction, that's fractional power. Now we have, instead the numerator forms the root. Okay, is treated as the root of that's third root. Okay, now 125 enters the root with this denominator as the power. So the denominator is treated as power of the value inside the root. Okay, now we now have third root of 125 is equals to 5. How do we know? What I mean is, what this means is, what number can you multiply up to 3 number of times to give you 125? And it is 5. If you multiply 5 by itself up to 3 number of times, you will get 125. 5 times 5 is 25. 25 times 5 is 125. Okay, so the answer is 5. That third root of 125 is equals to 5. Now power of 2 was there, so we now have 5 raised to power 2 is equals to 25. Okay, that's it for this one. Now note this. I want you to, this thing confuses many new elementary students and some other people. Now let's say this is times, this is division, this is plus, this is minus. When we say minus times minus is equals to plus, okay, minus times plus is equals to minus. Plus times plus is plus, of course. Plus times minus is equals to minus. In other words, when you're dealing with times, if the signs are the same, it always results to plus. That's minus minus, plus, plus plus, plus. But when the signs are different, it results to what? Negative. Okay. All right. Now look at this one under division. The division is just the same thing with the multiplication. Okay. Just check it out and then you get it. You can press pause and then check it out. All right. Now we have, because this is, when you talk about this is minus, will cancel this minus. Okay, giving us plus, and then plus plus is still plus. Okay. All right. Now under plus, look at this. We say minus 2 plus bracket minus 5. Okay, that is minus plus minus is equals to minus 2 minus 2 minus 5 equals to, because plus minus is equals to minus. Okay, now equals to minus 7. So here we have minus, that's this minus 2, you're owing 2, you owe 5, you'll be owing 7. Okay, that's, we have minus 2 plus 5 is equals to positive 3. That's, you have, you are owing 2, you got 5. When you pay the 2, you'll be having 3. 2 plus 5, of course, is 7. 2 plus minus it gives us minus. You have 2, you bought 5. When you pay the 2, you'll be owing 2, you'll be owing 3. All right, here we have minus 2 minus bracket minus 5 equals to minus 2 plus 5 equals to 3. Of course, minus times minus is equals to plus. Okay, so minus 2 plus 5 is equals to 3. You're owing 2, you got 5. When you pay the 2, you're owing, you'll be having 3 more. Having is positive. All right, we have minus 2 minus 5. You're owing 2, you owe 5, you'll be owing 7. 2 minus 5, you have 2, you bought 5, you'll be owing 3 when you pay the 2. 2 minus minus 5 is minus minus is equals to plus. 2 plus 5 is equals to 7.